All right, in this video, let's take a look at the three typical variables associated with circuits and with current electricity that we'll come across a lot. That is voltage, current, and resistance. Now, voltage, you can think about, it's also called electric potential. So it's related to potential energy. So I think a good way to think of voltage is it's the amount of energy available that can push electrons through a circuit. So the higher the voltage, the higher the potential energy available that can actually move electrons when they're put connected to the terminals in a battery. So if you think about a battery or a typical power supply, sometimes we'll call them, the batteries that we plug into the wall, that have a positive and a negative end, they might have what we call a potential difference of from 0 volts to 1.5 volts. What that means is at the positive terminal, there's 1.5 volt of potential energy available for electrons to flow when the whole battery from one end to the other is connected up. And it's actually a potential difference, which you don't really need to know, other than if you think of gravitational potential energy, we always use the ground as 0, so you always have to choose a reference point. We just measure from the ground. In terms of voltage, we use basically the negative terminal of the battery or the power supply as our 0, as our ground. So we measure how much energy is available in the battery by measuring up from 0, which was the potential at the negative end of a battery. Another way you can think about voltage is in terms of the water definition, it's the push, it's pressure in a way, in a sense. It's the kind of the strength of the electric field, to bring in something that we've talked about before. And that electric field, when connected, allows electrons to flow from one side to the next. Which gets us to our second major idea here, which is current. Now, current is mostly defined as the flow of electricity. So, in terms of our battery and our like a basic circuit, if we have a battery that has a voltage, so it has some electric potential energy to be able to push current through a circuit, and we use, let's say, a light bulb, that's a symbol for a light bulb, and we connect that light bulb to both sides of the battery. Now remember, we need to have the complete path for current to flow. If I break the path, there's no connection from the one side of the battery to the other, and I don't get any flow. But if I do connect that, what happens is the buildup of electrons actually can push, and it pushes on other electrons in the wire and makes its way. The electrons push through the light bulb, and they heat it up. When they heat it up, it glows. Right? And they continue on their path all the way to the positive end. Oops, that's a negative. Positive end of the battery. So to measure the current, I'm measuring the flow. So the more electrons that are moving, the more current I have in my circuit. Okay. The last thing that is going to come up a lot, that's a major variable we need to define, this idea of resistance in electrical circuits. And resistance is, it's a way to measure the difficulty of pushing current through a circuit. Well, what does that mean? That means if I have something that has a high resistance, examples of those would be things that were insulators, right? If you remember from our last unit, insulators were objects that do not allow electrons to flow through them very easily. The electrons are kind of fixed, so if I try to push with a voltage, an electric field through the insulator, I'm not gonna get much current to flow. I'm not gonna be able to free any electrons up to kind of push the other electrons through that material. So they would have a really high resistance. A low resistance would be things that are conductors. They have lots of free electrons, right? And those electrons can push on other electrons and generate higher currents. So if we want to go back to the water analogy, current is like the water flowing down the waterfall. Resistance would be the impediments to allowing that flow to go through. So if you can think kind of conceptually, something with a really high resistance, if you're trying to push current through it, you're not going to get as much. Whereas with a really low resistance, you're going to be able to push more current through. So that's why we use conductors to transmit electricity to the objects in our house that we plug into our outlets and to our lights, because they can more easily pass that electrical energy through the circuit to get things to operate. And that's voltage, current, and resistance.